One of the important property of the CES production function is that its elasticity of substitution is constant. So we will prove in this video. We are given the CES production function, which is given as a bracket alpha k to the power minus beta plus 1 minus alpha l to the power minus beta to whole power minus 1 divided by beta, where a is the efficiency parameter, a is the distribution parameter, and b is the substitution parameter, as we have seen in the earlier video. Now, how will we prove this? First order condition requires that the ratio of the marginal products should be equal to the input prices. That is, first order condition requires FOC, that is first order condition requires that marginal product of labor divided by marginal product of capital should be equal to the PL divided by PK. That is, the ratio of the marginal products should be equal to the ratio of the prices. That means this MPL we can write it as marginal productivity of labor, as we know is the first derivative of this very production function. That is, MPL is calculated by, that is DQ divided by DL. Similarly, the marginal productivity of capital is dq divided by dk. That means partially differentiating the given production function with respect to L and K gives us the marginal productivity of labor and capital. It should be equal to the input price ratios. Now we have to first calculate the this derivative dq divided by dl, that is marginal productivity of labor, and then the marginal productivity of capital. We will derive the marginal productivity of labor, that is dq divided by dl is equal to, that means we have to differentiate partially this very production function with respect to L. Now, as we know, this minus 1 divided by beta will become coefficient, because by the generalized power function rule of the differentiation, this becomes coefficient. So I will write minus 1 divided by b. We have this a, then we have this alpha k to the power minus beta plus 1 minus alpha, and L to the power minus beta, and this exponent is subtracted by 1, that is minus 1 divided by beta minus 1. And we have to internally differentiate this also by the rule of differentiation, as I have shown in earlier videos. Now the derivative of this L to the power minus beta, similarly this minus beta will become coefficient, so I will write here minus beta, and we have 1 minus alpha, 1 minus alpha, L to the power minus beta minus 1. So this is how we do the differentiation. Now here we can see this beta and this beta will get cancelled. This minus into minus is plus. We are with this, that is a alpha k to the power minus beta plus 1 minus alpha L to the power minus beta to the whole power. Now in place of this minus 1 divided by b minus 1, this minus 1 divided by b minus 1, it can be written as minus 1 minus beta divided by b, which is equal to minus 1 plus b divided by b. So the exponent becomes minus 1 plus beta divided by b, and we have this 1 minus alpha here, 1 minus alpha, L to the power. Now factoring minus 1 common, so this will become minus 1 plus beta. Okay. Now what will we do? This a, in place of a we can write a is equal to a1 to the power 1 plus b divided by a to the power beta, because this a to the power 1 times a to the power beta divided by a to the power beta, a to the power beta and a to the power beta will get cancelled, and we will get this a. So I will write it here. So this is how in place of a we will write this very expression. So I will write first this 1 minus alpha. Further simplifying, I will write 1 minus alpha. In place of a I will write this. In place of a I will write a to the power 1 plus beta divided by a to the power beta, and we have this alpha k to the power minus beta plus 1 minus alpha L to the power minus beta and we have this minus 1 plus beta divided by b beta, and L to the power minus 1 plus beta. Now here we can see that this very function, this very expression is equal to, so in place of this I will write first we have 1 minus alpha divided by a to the power beta, and in place of this we can write q to the power 1 plus beta. Why? Because our q is this very expression. Now q 1 plus beta will be this very expression. It can be clearly seen that this is equal to q to the power 1 plus beta. This very expression, because it is manipulation, the given manipulation of this very expression. So in place of this I write q to the power 1 plus beta, and we are left with L to the power minus 1 plus beta. So in place of L, I can write it as, to save space, I will simplify it here. In place of this, I can write 1 divided by L to the power 1 plus beta. By the very simple rule, as we know, x to the power minus n is equal to 1 divided by x to the power n. The exponent becomes positive and taking it to the denominator. So further simplifying this will become 1 minus alpha divided by a to the power beta, and I can write here q divided by L to the whole power 1 plus beta, because the exponents are here. Here the exponent is 1 plus beta, here also 1 plus beta. We can write q divided by L to the power 1 plus beta. Implies our dq divided by dl, that is marginal productivity of capital, is equal to this very term 1 minus alpha divided by a to the power beta, and we have q divided by L to the power 1 plus beta. Similarly, we can show that marginal productivity of capital is equal to, that is dq divided by dk, that will be equal to, because of the lack of the space I can't show this very expression. You can easily calculate the marginal productivity of capital, which will come out to be alpha divided by a to the power beta q divided by k whole power 1 plus beta. So this is our marginal productivity of capital. This is our marginal productivity of labor. Let this be equation second, this be third, and this be first equation. Now inserting the value of equation third and second in equation first, that is put equation 2 and third in first. That means we can write a dq divided by dl. In place of them we will write these very expressions. Now dq divided by dl is equal to this expression, so I will write it here, or I will write in place of this, or I will write this 1 minus alpha divided by a to the power beta, and we have q divided by L whole power 1 plus beta divided by alpha divided by a to the power beta, and q divided by k to the whole power 1 plus beta, which is equal to PL divided by PK. That is equal to PL divided by PK. Now further solving this very equation, this very expression, we can write it as, this can be written as 1 minus alpha divided by a to the power beta times reciprocating this denominator, this very expression, this will become a to the power beta divided by alpha. Similarly, we can expand this. This will become q to the power 1 plus beta divided by L to the power 1 plus beta. Similarly, reciprocating this value, this will become k to the power 1 plus beta divided by Q to the power 1 plus beta, which is equal to the input price ratio, that is PL divided by PK. Now here some terms will get cancelled, so we will see which one will get cancelled. This A to the power beta, A to the power beta, Q to the power 1 plus beta will get cancelled with this term. So we are with this 1 minus alpha divided by alpha here, and we are with this K to the power 1 plus beta, L to the power 1 plus beta. So they are in fractions, in numerator and denominator, and we can write them as K divided by L whole power 1 plus beta. So this is our, this should be equal to that is equal to PL divided by PK here. Okay, that means we can further manipulate this. I can write it as I will write K divided by L to the whole power 1 plus beta is equal to PL divided by PK, and transposing this very expression on RHS, so this will get reciprocated, and we are with this alpha divided by 1 minus alpha. Further solving this, now transposing this power on the RHS, this will become 1 divided by the given power. So that means K divided by L is equal to PL divided by PK whole power 1 divided by 1 plus beta, and similarly the power will get also to this very expression alpha divided by 1 minus alpha whole power 1 divided by 1 plus beta. This is very simple. You can see if we are given x to the power n is equal to y, we can write it as x is equal to y to the power 1 by n. That very rule I have applied here. I have taken the bar on K and L to show that this is the dependent variable, this is the independent variable. That is, since here alpha and betas are the constant, that means capital labor ratio is the function of this input price ratio. That means this is the independent variable, and this is the dependent variable. Now let us say in place of this very expression, this is equal to h. Let h is equal to alpha divided by 1 minus alpha to the whole power 1 divided by 1 plus beta. Then our expression will become, that is K divided by L is equal to h times PL divided by PK to the power 1 divided by 1 plus beta. Now coming to the elasticity of substitution. Elasticity of substitution is the measurement of how a change in the least cost to capital labor ratio changes resulting from a small change in the input price ratios. That is elasticity of substitution. I will write here elasticity of substitution measures the percentage change in the least cost capital labor ratio resulting from small percentage change in input price ratio. That is to say, I will write here elasticity of substitution is equal to, that is equal to d K by L divided by K by L whole divided by d PL divided by PK whole divided by PL divided by PK. Now this means, this shows percentage change in the capital labor ratio with a small percentage change in the input price ratios. This gives us the elasticity of substitution. Now we have to calculate then this very dkl divided by dk, or I can write it as, it can be written also like, I can write it as del k by l divided by del pl divided by pk whole divided by k by l divided by pl divided by pk. I can write it as either. That means if we are this very expression, that means we have to differentiate this very function with respect to the input price ratio, that is with respect to PL divided by PK. This is our marginal function, so I will write here. This the denominator here, this is marginal function, marginal divided by average function, because this is the incremental change, and capital labor ratio divided by the input price ratio gives us the average function. Now we will calculate this also here. Coming to the next step, what we have to do, we have to differentiate this very function. That means I will write here del k by l divided by del pl by pk. Now differentiating this very function with respect to PL by PK. So we have, actually we will differentiate this very, because h in place of h, we have this very expression, so it will be very easy to differentiate here. Simple rule is this exponent becomes the coefficient and exponent is subtracted by 1. So this will become h divided by 1 plus beta, because 1 divided by beta, 1 divided by 1 plus beta times h is equal to h divided by 1 plus beta, and we have PL divided by PK, and this exponent is subtracted by 1 by the rules of differentiation, 1 plus beta minus 1. So this is the differentiation of this. This is the marginal function. Similarly, we will see the average function here. Now average function is our, that is KL divided by PL divided by PK. Now this is our K by L, is this very expression we divided by PL by PK. That means our, so I will write it here. This is our marginal function. This is the marginal function. I will write it. This is marginal function. This is marginal function. Similarly, we will write the average function. Now our average function is equal to KL ratio, that is this very expression, that is H PL by PK to the whole power 1 divided by 1 plus beta, 1 divided by 1 plus beta, and dividing it by this PL by PK. PL by PK. So this is our marginal function. Now elasticity of substitution is equal to marginal function divided by average function. Now putting the values here, our marginal function is this, that is h divided by 1 plus beta. We have this PL divided by PK to the 1 by 1 plus beta minus 1 divided by. Now here we can do one thing. I can write it as h is equal to PL by PK to the power 1 divided by 1 plus beta minus 1. Why? Because here bases are same, we can subtract the exponents, because PL by PK whole power 1 divided by 1 plus b, we have PL by PK. So when transposing it to the numerator, this will become the negative exponent. Then adding those two will give us 1 divided by 1 plus b minus 1.
Now elasticity of substitution is equal to, that is denoted by rho, which is equal to marginal function divided by average function. Our marginal function was, I will write here, h divided by 1 plus beta pl by pk to the whole power 1 divided by 1 plus beta minus 1, and our average function was h pl by pk to the whole power 1 divided by 1 plus beta minus 1. Now solving this, this will become, now this very term will get cancelled with this. We are left with this, here it is h divided by 1 plus beta, and reciprocating this h will become 1 divided by h. So our elasticity of substitution is equal to 1 divided by 1 plus beta, which is constant here. That means the value of this elasticity of substitution is constant, whose magnitude depends on the value of parameter b. It depends only on this very parameter, and it doesn't depend upon the input price ratio or capital labor ratio. It is value depends upon this very parameter. So this I will write here, this elasticity of substitution is constant whose value or whose magnitude depends on the value of parameter beta. Now if I will write here, if the parameter b lies between 0 and minus 1, that is the value of b is between 0 and minus 1, in this case our elasticity of substitution will be greater than 1. That means any value which is between minus 1 and 0, let us say we have the value of beta is here 0.5, that is equal to, therefore elasticity, let us say beta is equal to 0.5, that is minus 0.5, which lies between 0 and minus 1. So this will become 1 plus minus 0.5 here. This becomes 1 divided by 1 minus 0.5 is 0.5, which is equal to 1 divided by 2, which is equal to 2, implies elasticity of substitution is 2, which is greater than 0. If beta is equal to 0, at that time our elasticity will be equal to 1, which is simple. Put the value of beta is equal to 0 in this, so this will become 1 divided by 1 plus 0, implies elasticity is equal to 1 divided by 1, which is equal to 1. Similarly, if beta lies between 0 and infinity, that is beta is greater than 0 and less than infinity, in this case our elasticity of substitution will be less than 1. Take any value between 0 and infinity. Let us say we take 2, then let beta is equal to 2, because 2 lies between 0 and infinity. Then this will become, elasticity of substitution will become 1 divided by 1 plus 2, which is equal to 1 by 3, which is less than which is less than 1. 1 divided by 3 is 3.33, implies rho or elasticity of substitution is equal to 0.33, which is less than 0. So the bigger the number in the denominator, the whole fraction becomes smaller. So this is to be remembered here.